Hello there and welcome. Tonight, we're exploring perhaps the most profound mystery of all. What came before the Big Bang? It's a question that stretches our minds to the very edges of existence itself, like standing at the shore of an infinite ocean and wondering what lies beyond the horizon of all horizons. Before we journey to the beginning of everything, I'd love to know, where are you listening from tonight? And what time is your corner of this ancient universe showing? Perhaps it's late evening where you are, the world settling into that familiar quiet that comes when the day's responsibilities finally release their grip. Maybe you're tucked under soft blankets, feeling that gentle weight that signals the approach of sleep. Or perhaps you're in that liminal space between waking and dreaming, where the mind becomes most receptive to wonder, and the heart opens to mysteries that daylight seems to chase away. Fitting, isn't it, pondering the birth of time itself while nestled in your own quiet moment. Here you are, a collection of atoms that were forged in the hearts of dying stars billions of years ago, now arranged in such a way that they can contemplate their own cosmic origins. Those same atoms have been part of mountains and oceans, flowers and other human beings, all before finding their way to this precise configuration that is uniquely, temporarily, beautifully you. And now, in this moment, those ancient stellar remnants are using their borrowed existence to wonder about the very beginning of the story they're all part of. There's something deeply moving about this, isn't there? The universe has spent 13.8 billion years evolving, expanding, cooling, forming galaxies and stars and planets, developing the chemistry of life, nurturing the slow dance of evolution, all so that eventually, on one small world orbiting an unremarkable star, consciousness could emerge and turn its attention back toward the cosmic mystery of its own birth. You are, in a very real sense, the universe becoming aware of itself, a temporary arrangement of matter and energy that has achieved the remarkable feat of self-reflection. And tonight, that self-reflection is carrying you back to the ultimate question. Where did all of this come from? The question itself is almost impossibly ambitious. We're not asking about the origin of our solar system, or even our galaxy, or even the observable universe with its hundreds of billions of galaxies. We're asking about the origin of space itself, time itself, the very stage upon which all existence plays out. It's like a character in a play suddenly becoming aware of the theater, the audience, the playwright, and then asking who built the theater and what existed before the first word was ever written. The audacity of the question is matched only by its intimacy, because this isn't just an abstract intellectual puzzle. This is the story of how you came to be here now, breathing softly in the darkness, contemplating infinity. What makes this question even more beautiful is that it sits at the intersection of our deepest scientific knowledge and our most profound ignorance. We know so much about how the universe evolved after that first moment. We can trace the formation of the first atoms, the birth of the first stars, the slow accumulation of heavy elements that made planets possible, the emergence of life and eventually consciousness. But when we try to peer back to that very first instant, our knowledge hits a wall as mysterious and impenetrable as the darkness behind your closed eyelids. It's humbling, really, to realize that for all our technological prowess and scientific understanding, we are still like children standing before an enormous locked door, wondering what lies beyond. And perhaps that's as it should be. Perhaps some mysteries are meant to remain mysterious, not because they're unsolvable in principle, but because the act of wondering, of reaching toward the unreachable, is itself a fundamental part of what makes us human. Every generation has asked this question in their own way, using their own language, their own understanding, their own metaphors, drawn from their experience of being alive in a world that is both utterly familiar and completely mysterious. Tonight, as you settle into the approaching embrace of sleep. You're participating in this ancient human tradition of cosmic wondering. The beauty of approaching this question at bedtime is that sleep itself is a kind of miniature mystery, isn't it? Every night, your consciousness fades into something we don't fully understand, a state where time becomes fluid, where impossible things seem perfectly reasonable, where you might find yourself having conversations with people who died years ago or flying through landscapes that exist nowhere but in the theater of your dreaming mind. In a way, falling asleep is your nightly journey to the edge of existence, a gentle rehearsal for the ultimate mystery of consciousness itself. So as we explore tonight what might have existed before the beginning of everything, we're really exploring the deepest questions about the nature of existence itself. Questions that connect the vast cosmos to the quiet intimacy of your own experience of being aware, of being alive, of being here. If this voyage brings you peace, if these gentle wanderings through cosmic mystery help quiet the busy thoughts of your day, perhaps consider giving it a like or subscribing to this little corner of nocturnal wonder. It helps these midnight musings reach other restless minds seeking the same gentle balance of curiosity and calm that you're seeking tonight. Now, settle in more deeply. Let your breathing slow and soften, and prepare for a journey to the edge of existence itself. Feel the weight of your body against whatever surface supports you. Notice how your muscles are beginning to release the day's accumulated tension, how your thoughts are starting to move more slowly, more dreamily. This is the perfect state of mind for contemplating the ultimate mystery, because it's when we're most relaxed, most open, most willing to let our imaginations stretch toward ideas that our more wakeful, practical minds might find too strange to entertain. Because somewhere before the first moment, before space and time began their cosmic dance, before there was any where or any when at all, lies a mystery so deep that even asking the question might be the wrong approach entirely. It's a bit like asking what the color blue tastes like, or what the sound of silence sounds like. We're pushing language and concepts beyond their normal boundaries, trying to use tools designed for navigating everyday reality to explore something that exists outside of everyday reality entirely. What came before everything? The question itself is loaded with assumptions that might not apply. The word before implies time, but if time itself began with the Big Bang, then before might be meaningless. The word what implies something, some entity or state or condition, but if space itself began with the Big Bang, then there might not have been any where for a what to exist. The word came implies a process, a transition from one state to another, but if causality itself is bound up with time, then perhaps the very notion of something coming from something else breaks down at the ultimate boundary of existence. And yet, despite these logical puzzles, the question continues to tug at something deep in the human heart. We are storytelling creatures, pattern-seeking beings who find meaning through narrative and sequence. We want to know the beginning of the story, even if the beginning is stranger than any story we could imagine. We want to trace the thread of causation back to its source, even if that source exists beyond the reach of causation as we understand it. We want to find the foundation upon which everything rests, even if that foundation is itself foundationless. Let's begin this tender expedition to the very beginning, or perhaps to what preceded all beginnings, keeping in mind that every step we take is both a step toward understanding and a step into deeper mystery. Like explorers venturing into uncharted territory with maps that become increasingly blank the farther we travel, we'll navigate by the light of scientific discovery, philosophical speculation, and that peculiarly human capacity to find wonder even in the face of the incomprehensible. Tonight's journey will take us through landscapes of thought that are both utterly alien and strangely familiar. We'll encounter ideas that challenge our most basic assumptions about reality, while somehow still feeling like they might be true. We'll explore theories that sound like science fiction, but emerge from our most rigorous scientific thinking. We'll grapple with concepts that simultaneously expand and humble our sense of human significance in the cosmic order. As we embark on this gentle expedition, remember that the goal isn't necessarily to arrive at a definitive answer. The universe's greatest mysteries rarely offer such satisfaction. Instead, the goal is to let our minds wander freely through the garden of cosmic possibility, to feel the peculiar pleasure that comes from stretching our understanding toward its limits, to experience that sense of awe that arises when we truly contemplate the magnitude and mystery of existence itself. In the end, the question of what came before the Big Bang is less important than what happens inside us when we allow ourselves to seriously consider it, when we permit our consciousness to expand toward the edges of the knowable and peer, however briefly, into the vast darkness of the unknown. So breathe deeply, let your thoughts flow as gently as water, and prepare to explore the most profound mystery of all, the origin of everything, including the very concepts of origin and everything themselves. First, let's remember what the Big Bang actually describes, because before we can wonder what came before it, we need to understand what it was, or perhaps, more accurately, what it wasn't. The Big Bang wasn't an explosion in the way we normally think of explosions. It wasn't a bomb going off in empty space, sending matter flying outward into a pre-existing void. That's the common misconception, the image that comes to mind when we hear the word bang, but the reality is far stranger and more subtle than any explosion we could witness or imagine. About 13.8 billion years ago, our universe began expanding from an incredibly hot, dense state. Though even using the word began is already a tricky proposition that we'll need to handle with care. It wasn't that space was there first, waiting to be filled with expanding matter and energy. Instead, space itself was expanding, stretching, growing, carrying matter and energy along for the ride like passengers on a cosmic escalator that was building new steps beneath their feet even as they rode upward. Picture a deflated balloon that suddenly begins inflating, but here's the crucial part. The balloon is all of existence, and there's nothing outside it. There's no room the balloon is expanding into, no larger space that contains it. The balloon is space itself, and as it expands, it creates the very volume it's expanding into. It's a mind-bending concept that challenges our everyday experience of how things work, because in our daily lives, when something expands, it expands into something else. A rising loaf of bread expands into the oven's space. A growing plant expands into the garden's soil and air. But the expanding universe has nothing to expand into because it is the totality of space itself. In those first moments, the universe was smaller than an atom, yet contained everything that would ever exist, all the matter that would eventually form hundreds of billions of galaxies, each containing hundreds of billions of stars, along with all the dark matter and dark energy that we're only beginning to understand. It was hotter than anything we can properly imagine, hotter than the center of the most massive stars, hotter than the collision of black holes, hotter than any earthly analogy could capture. The temperature was so extreme that the familiar particles we know today, protons, neutrons, electrons, couldn't even exist. Instead, there was a seething soup of more fundamental entities, a plasma of quarks and gluons and other exotic particles that normally only appear in our most powerful particle accelerators for the briefest of moments. And it was expanding faster than we can properly describe, not just faster than the speed of light, which would be remarkable enough, but accelerating in its expansion, growing exponentially, doubling in size again and again in intervals so small that we need scientific notation just to write them down. In a tiny fraction of a second, something smaller than a proton expanded to the size of a grapefruit, then to the size of a planet, then to something vastly larger than our solar system, all while remaining incredibly hot and dense by any standard we might apply today. But here's where our story becomes both more precise and more mysterious. We can trace this expansion and cooling with remarkable accuracy up to a certain point. We can describe how the first protons and neutrons formed when the universe was about 1 second old, how the first atomic nuclei formed when it was about 3 minutes old, how the first complete atoms formed when it was about 380 years old, creating the cosmic microwave background radiation that we can still detect today, a faint afterglow of that ancient moment when the universe first became transparent to light. We can follow the story through the formation of the first stars, the first galaxies, the slow enrichment of space with heavy elements forged in stellar cores, the birth of planets, the emergence of chemistry complex enough to support life, and eventually the evolution of consciousness capable of looking back and piecing together this entire cosmic narrative. It's an extraordinary story, one of the most remarkable achievements of human curiosity and ingenuity, this ability to read the history of everything in the light of distant stars and the whisper of ancient radiation. But as we trace this story backward, as we follow the thread of cosmic history back toward its beginning, something strange happens. Our understanding becomes less certain, our theories more speculative, our mathematics more exotic. The closer we get to that first moment, the more elusive it becomes, like trying to approach an oasis that recedes with every step forward. The temperatures and densities we're describing in those earliest moments are so extreme that they push our theories beyond their tested limits. The energies involved are higher than anything we can reproduce in our laboratories, the conditions more extreme than anything that exists anywhere in the universe today. We're extrapolating our knowledge into a realm where we can't be certain our extrapolations remain valid, like using a map of your neighborhood to navigate a different planet. And as we approach that first instant, that moment of beginning, our confidence gives way to honest bewilderment. The very concepts we use to describe physical reality, space, time, causality, energy, matter, all seem to break down or transform into something unrecognizable. It's as if we're trying to describe a symphony to someone who has never heard music, using a language that has no words for melody or harmony or rhythm. This is where we stand at the edge of our knowledge, looking back toward the ultimate horizon of understanding, knowing that everything we can observe and measure and comprehend emerged from something that lies just beyond our ability to observe or measure or comprehend. It's humbling and thrilling at once, this recognition that the entire story of existence springs from a mystery that may be deeper than any mystery we've yet encountered. But here's where things get beautifully strange, where our journey toward understanding encounters its most profound and humbling boundary. Physics, as we understand it, breaks down at the very beginning, not gradually or gracefully, but suddenly and completely, like a perfectly clear photograph that becomes increasingly blurry until it dissolves into pure abstraction. Our equations work wonderfully, with breathtaking precision and elegance, until about 10 to the minus 43 seconds after the Big Bang, H, that's 0.00000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 point would be followed by 42 zeros before you reached the first significant digit. This impossibly brief moment is called the Planck time, named after Max Planck, one of the founders of quantum theory, and it represents the smallest meaningful unit of time that our physics can describe. It's not that nothing happened before the Planck time, but rather that our current theories simply cannot tell us what happened. It's like trying to read a book where the first page has been torn out, and we're left wondering what the opening sentence might have been, except in this case, we're not even sure if there was a first page at all, or if the very concept of first has any meaning in this context. At the Planck time, the universe was at what we call the Planck scale, in all dimensions, not just time, but space and energy as well. The entire observable universe, everything we can see with our most powerful telescopes, All of it was compressed into a region smaller than the Planck length, which is about 10 to the minus 35 meters across. To put this in perspective, if an atom were scaled up to the size of our solar system, the Planck length would still be smaller than a human hair. We're talking about distances so small that the very notion of distance, as we normally understand it, begins to lose meaning. At these scales, the smooth fabric of space-time that Einstein described begins to look more like a turbulent, foaming sea. Quantum effects, which we can safely ignore at everyday scales, become the dominant feature of reality. Virtual particles pop in and out of existence with such frequency and energy that space itself becomes uncertain, probabilistic, more like a cloud of possibility than the solid stage we normally imagine. The gentle geometry of space-time gets twisted into impossible shapes, creating loops and bubbles and connections that exist outside our normal understanding of cause and effect. This is where our two most successful theories of physics, general relativity and quantum mechanics, start giving nonsensical answers when pushed to their limits. General relativity, Einstein's beautiful description of gravity as the curvature of space-time, works magnificently for describing black holes, the expansion of the universe, and the motion of planets. Quantum mechanics works with equal magnificence for describing atoms, molecules, and the fundamental forces that govern matter and energy. But when we try to combine them, when we need both theories to describe the same phenomenon, when down as we must when dealing with the extreme conditions near the Big Bang, they refuse to cooperate. It's like having two different languages, each perfectly suited for describing its own domain, but completely incompatible when we need to translate between them. General relativity speaks of smooth, continuous curves in space-time, while quantum mechanics speaks of discrete, probabilistic jumps between states. General relativity assumes we can measure position and momentum with perfect precision, while quantum mechanics insists that such precision is fundamentally impossible. At the Planck scale, these contradictions become unavoidable, and our theoretical framework simply breaks down. The mathematics that normally provides such elegant descriptions of physical phenomena starts producing infinities, undefined quantities, results that make no physical sense. It's not that the math is wrong. The same equations work perfectly well in less extreme situations. It's that we're asking them to describe something beyond their domain of applicability, like trying to use the rules of checkers to play chess, or the principles of cooking to build a spacecraft. Some physicists compare this situation to early maps of the world, where cartographers would write, "Here be dragons," in regions they hadn't yet explored. Beyond the Planck time lies a realm where our current maps of reality simply end, and we're left to wonder what strange territories might exist there. The dragons, in this case, might be even stranger than anything ancient mapmakers imagined, regions where time flows backward, where cause and effect reverse their usual relationship, where the distinction between existence and non-existence becomes meaningless. This breakdown isn't a failure of physics, though it might feel like one. It's more like a signpost marking the edge of our current understanding, an invitation to develop new theories, new mathematical tools, new ways of thinking about the deepest levels of reality. Just as Newton's physics gave way to Einstein's relativity when pushed to extreme speeds and masses, our current theories may need to give way to something even more fundamental when pushed to the extreme conditions of the cosmic beginning. The humbling beauty of this situation is that it reminds us how much mystery remains in the universe, how much wonder still awaits discovery. We live in an age where we can measure the universe's age to within a few million years, where we can detect gravitational waves from black holes colliding billions of light years away, where we can observe galaxies that formed when the universe was barely out of its infancy. And yet, the very first moment of everything remains as mysterious as it was to our ancestors, who looked up at the night sky and wondered about their place in the cosmic order. So what was there before? The simplest answer, the one that first comes to mind when we strip away all complexity and theory, is nothing, just nothing at all. But nothing is far more complex and mysterious than it sounds when you're trying to fall asleep to cosmic mysteries, when your mind is settling into that dreamy state where impossible things begin to seem almost reasonable. The word nothing feels simple, clean, final, like closing a book or turning off a light. But when physicists use the word nothing, they're describing something that might be the most puzzling concept in all of science. In our everyday experience, nothing is easy to understand. Nothing is what's in an empty box, what's left after you've eaten all the cookies, what exists in the space between your hands when you hold them apart. It's absence, void, the lack of something where something could be. When children ask what's in an empty room, we say nothing, and they understand perfectly well what we mean. But this everyday nothing, this absence of things in space, isn't what physicists are talking about when they discuss the state before the Big Bang. In physics, even empty space isn't truly empty. Packin, it's filled with quantum fields, those strange mathematical entities that permeate every cubic centimeter of the universe. These fields are like invisible oceans of potential, always present, always humming with activity, even when nothing visible is happening. Virtual particles pop in and out of existence constantly, borrowing energy from the vacuum itself for impossibly brief moments before annihilating each other and returning the energy they borrowed. It's a sort of energetic buzz that permeates reality, a quantum foam of possibility that underlies everything we see and touch and measure. Think of it like the surface of a perfectly still pond. From a distance, it looks smooth and empty, but if you could examine it closely enough, you'd see tiny ripples, microscopic waves, the constant subtle motion of molecules, even in the calmest water. The quantum vacuum is like that, apparently empty from our perspective, but seething with activity at scales we can't directly observe. These quantum fluctuations aren't just theoretical curiosities, they have measurable effects. They influence the behavior of atoms. They contribute to the forces between particles. They even play a role in the evaporation of black holes. So when we say nothing existed before the Big Bang, do we mean no space, no time, no energy, no potential for anything at all? Do we mean the absence even of these quantum fields, the absence of the stage upon which virtual particles might dance their brief existences? It's like trying to imagine a color that doesn't exist, or a sound made in perfect silence, or the experience of consciousness without any content whatsoever. We're pushing our concepts beyond their normal boundaries, trying to use mental tools designed for navigating a world of something to explore a state of absolute nothing. But even this gets more complicated when we consider what physicists call the false vacuum. In quantum field theory, what we think of as empty space might not be the lowest possible energy state. It might be more like a ball resting in a shallow valley, apparently stable but capable of rolling down to an even lower state if given the right push. If our vacuum is false, then true nothingness, the genuine ground state of reality, might be even more empty than the apparent emptiness we observe around us. The implications are both fascinating and slightly unsettling. Our entire universe might exist in a metastable state, like a pencil balanced on its point, technically possible but ultimately unstable. This leads to even stranger possibilities. Some theories suggest that the quantum vacuum is inherently unstable, that perfect nothingness cannot maintain itself. In this view, nothing naturally and inevitably gives rise to something through purely quantum processes. It's as if nothingness itself is allergic to its own existence, constantly breaking out in a rash of virtual particles and energy fluctuations. The universe, in this picture, might be the inevitable result of nothing's inability to remain nothing for very long. The mathematical description of this process is beautiful and bewildering. In quantum mechanics, even empty space has a minimum energy level, called zero-point energy, that cannot be removed. This isn't just a theoretical artifact. It's something we can measure in laboratory experiments. The Casimir effect, for instance, demonstrates that the quantum vacuum between two closely spaced metal plates actually exerts a measurable force, pushing the plates together. Empty space, it turns out, has structure, properties, behavior. It's not nothing in any sense we would normally recognize. When we try to imagine what existed before the Big Bang, we're forced to consider whether there could be something even more fundamental than this quantum vacuum, something deeper than the deepest level of nothingness our theories can describe. Perhaps there was a pre-geometric state, a condition that existed before space and time themselves, before even the possibility of quantum fields or energy or the mathematical relationships that govern physical reality. But how do we conceive of such a state? How do we imagine something that precedes not just all things, but all possible things? Some philosophers have argued that asking what existed before the Big Bang is like asking what's north of the North Pole, a question that seems meaningful but ultimately has no answer because it misunderstands the nature of the thing being questioned. If time itself began with the Big Bang, then before becomes a meaningless concept, like asking what color Wednesday is or what the square root of purple might be. We're using temporal language to discuss a situation where temporality itself might not apply. Yet, despite these logical puzzles and conceptual difficulties, the question continues to haunt us. We are creatures of cause and effect, beings who find meaning in sequence and relationship. When we encounter something as profound as the origin of everything, our minds naturally reach for the familiar patterns of beginning and end, cause and consequence, before and after. The idea that these patterns might break down at the ultimate boundary of existence is both liberating and terrifying, like discovering that the rules we've lived by our entire lives are just local customs rather than universal laws. But perhaps there was no before at all. Perhaps time itself began with the Big Bang, emerging alongside space in one unified moment of cosmic birth. This possibility is somewhat comforting when you think about it deeply, like being told you don't need to worry about what happened before you were born, because before you didn't exist as a meaningful concept. In this view, asking what came before the Big Bang is like asking what's north of the North Pole, a question that seems meaningful but ultimately has no answer, because it fundamentally misunderstands the nature of what it's questioning. Time, in this scenario, isn't something that flows like a river through an eternal landscape, carrying events along from past to future. Instead, time is more like the landscape itself, inseparable from the space through which it extends. When the Big Bang occurred, it wasn't happening at a particular moment in pre-existing time. It was the moment when moment itself became possible, when the very concept of when first acquired meaning. Before that inaugural instant, there was no before, because there was no temporal framework in which before could be situated. Einstein's relativity has taught us that space and time are woven together into a single fabric called space-time, and this fabric can be stretched, curved, and manipulated by matter and energy. Near massive objects, time moves more slowly. At the event horizon of a black hole, time appears to stop entirely from an outside observer's perspective. If space-time is this flexible, this responsive to physical conditions, then perhaps it makes perfect sense that space-time itself could have a beginning, a first moment before which the very notion of moments is meaningless. Think of it like the surface of a sphere. You can travel in any direction on the surface, north, south, east, west, and each direction is meaningful and well-defined. But if you try to go north from the North Pole, the question becomes nonsensical, not because there's a barrier or a wall, but because you've reached the natural boundary of the surface itself. In the same way, if you trace the history of the universe backward through time, you eventually reach the Big Bang, the temporal North Pole of existence, beyond which the question, what came before, loses all meaning. This idea has profound implications for how we understand causality and existence. In our everyday experience, every event has a cause. Every beginning has something that preceded it. Every story has an earlier chapter. We expect the cosmic story to follow the same pattern. If the universe began, something must have caused it to begin. But this expectation might be a kind of category error, like expecting every number to have a predecessor even when you've reached the number 1, or expecting every sentence to have a previous sentence even when you've reached the first line of the first page of the first book ever written. The mathematics of general relativity supports this possibility. When cosmologists trace the expansion of the universe backward using Einstein's equations, they find that all the matter and energy we observe was concentrated in a single point of infinite density at time t equals 0. This singularity isn't just the beginning of stuff. It's the beginning of the stage on which stuff can exist, the first moment when existence itself becomes possible. But here's where this elegant solution encounters its own puzzles. If time began with the Big Bang, how do we account for the Big Bang itself? What triggered this inaugural moment? The question seems to require a kind of bootstrap causality, where the universe creates the conditions for its own creation. It's like a story that begins with, "Once upon a time, there was no time, and then time began," which is poetically beautiful, but logically challenging. Some physicists have proposed that the universe might be self-creating in a more literal sense. In certain interpretations of quantum mechanics and general relativity, the universe could be causally self-contained, a closed loop where the ending somehow gives rise to the beginning. It's reminiscent of those impossible drawings by M.C. Escher, where waterfalls flow upward to feed themselves, or staircases climb endlessly while somehow returning to their starting point. The universe, in this view, might be the ultimate impossible object, existing not because something created it, but because its existence is the only self-consistent possibility. Another way to approach this puzzle is through the concept of eternal existence. Perhaps the universe didn't begin to exist at all, but rather has always existed in some form, even if the form we're familiar with, expanding space filled with matter and radiation, only began 13.8 billion years ago. The Big Bang in this view isn't the moment when existence began, but rather a phase transition, like water turning to steam or a caterpillar becoming a butterfly. The underlying reality persists through the transformation, but its manifest properties change dramatically. This perspective finds support in some interpretations of quantum cosmology, where the universe is described as a quantum system that exists in a superposition of all possible states until it somehow selects or is forced into the particular configuration we observe. The Big Bang, then, might be the moment when this quantum superposition collapsed into a classical determinate reality, not the moment when reality itself began. Time and space emerged together, intertwined, in that first moment, creating the stage upon which all of cosmic history would unfold. There was no empty theater waiting for the play to begin, no cosmic clock ticking away in solitude. The theater and the play, the clock and time itself, all sprang into being simultaneously, creating their own context, their own meaning, their own raison d'être. In this view, the universe is like a novel that creates the language in which it's written, or a song that invents music in order to be heard. It's a bootstrap operation of the most profound kind, where existence creates the preconditions for its own possibility. And perhaps that's the most beautiful answer of all, not that something came before everything, but that everything contains within itself the source of its own being, the reason for its own existence, the answer to the question of why there is something rather than nothing. But perhaps the universe is more like a cosmic heart, beating in an eternal rhythm of expansion and contraction, a vast breathing organism that has been inhaling and exhaling for eternity itself. Some theories suggest our Big Bang was just the latest in an endless series of cosmic cycles, each one a single heartbeat in an infinite pulse that stretches backward and forward through time without beginning or end. It's an elegant idea that appeals to something deep in human nature, our love of patterns, rhythms, the comforting repetition of day and night, seasons cycling through their changes, the steady beat of our own hearts that started before we were born and will continue until the moment we die. In these cyclic models, the universe expands for billions of years, just as we observe it doing now, growing cooler and more dilute as space stretches and galaxies drift apart. But eventually this expansion slows, stops, and reverses. Gravity, that gentle but persistent force that brought the first stars and galaxies together, eventually wins its cosmic tug-of-war against expansion. The universe begins to contract, slowly at first, then with gathering momentum, pulling all matter and energy back together in what cosmologists call the Big Crunch. Imagine running a film of the Big Bang in reverse. Galaxies that have been flying apart for billions of years begin to approach each other. Stars that have been burning steadily for eons find themselves drawn into increasingly dense clusters. The cosmic microwave background radiation, That faint afterglow of the Big Bang that still whispers through space grows brighter and hotter as space contracts around it. Eventually, everything that was once scattered across hundreds of billions of light years gets squeezed back into a region no larger than our solar system, then no larger than Earth, then no larger than an atom. But here's where the cyclic models propose something beautiful and strange. Instead of ending in a final collapse, the universe bounces. Just as a ball thrown to the ground springs back up, the contracting universe reaches some minimum size, perhaps at the Planck scale we discussed earlier, and then rebounds in a new Big Bang. The cosmic heart completes one beat and begins another. All the matter and energy that was compressed to unimaginable density suddenly begins expanding again, creating new space, new time, a fresh cosmic epoch with new possibilities. This isn't just wishful thinking or poetic metaphor. The mathematics of some modified theories of gravity, particularly those that attempt to unify general relativity with quantum mechanics, naturally produce bouncing solutions. These equations suggest that at extremely high densities, quantum effects create a kind of repulsive force that overwhelms gravity, causing the collapse to reverse into expansion. It's as if space itself becomes elastic at the smallest scales, compressing only so far before springing back with renewed vigor. The beauty of cyclic cosmology is that it eliminates the problem of a beginning altogether. Instead of one mysterious moment when everything started, we have an infinite sequence of cosmic rebirths, each emerging from the ashes of the previous universe. Your bedtime tonight would be just one quiet moment in an eternal dance of cosmic nights and days, stretching endlessly in both directions through time. The atoms in your body have perhaps participated in countless previous universes, each one expanding, evolving, developing complexity, then contracting back to simplicity before beginning the cycle anew. Some versions of these models suggest that each cycle is identical to every other cycle. The same galaxies form, the same stars ignite, the same planets develop the same life forms. And eventually, the same conscious beings ask the same questions about cosmic origins. It's like a cosmic Groundhog Day, but played out over trillions of years instead of 24 hours. In this view, you've had this same conversation countless times before in previous cycles, and you'll have it countless times again in cycles yet to come. Other versions allow for variation between cycles. Perhaps the physical constants change slightly from one universe to the next. Gravity might be a little stronger or weaker. Light might travel at a different speed. The forces that bind atomic nuclei might be more or less powerful. Each cycle would then be like a cosmic experiment, testing different possible configurations of physical law. Most would produce universes hostile to complexity, but occasionally one would hit the sweet spot that allows stars and planets, and eventually life to flourish. There's something deeply comforting about the cyclic model, isn't there? Instead of facing the stark choice between a universe that began from nothing and one that has always existed in its current form, we get a cosmos that is both eternal and ever-changing, both familiar and endlessly creative. It's like an eternal spring that brings new life while following the same underlying patterns, or like music that explores infinite variations on eternal themes. The cyclic universe also addresses one of the deepest puzzles in cosmology. Why did our universe begin in such a special low-entropy state? In a typical Big Bang model, the universe starts out remarkably smooth and uniform, which seems incredibly unlikely if it began randomly. But in a cyclic model, each contraction phase acts like a cosmic eraser, smoothing out the lumps and irregularities that accumulated during the previous expansion. The universe doesn't need to start in a special state because the bouncing process naturally creates the smooth initial conditions we observe. This cosmic recycling also provides a satisfying answer to questions about ultimate fate. Instead of facing heat death, the bleak scenario where the universe expands forever, growing cold and empty as its stars burn out and its black holes evaporate, we get endless renewal. Every ending becomes a beginning, every cosmic winter followed by a cosmic spring. The universe never truly dies because death itself becomes just another phase in an eternal cycle of transformation. Of course, these models face their own challenges and mysteries. What mechanism could cause a universe to bounce rather than collapse completely? How could information and structure survive the crushing conditions near the bounce point? Why doesn't the universe's expansion accelerate indefinitely, as current observations suggest it's doing? These are active areas of research where theorists are still working out the details, still exploring the mathematical landscapes where cosmic cycles might hide. Then there's the possibility that our universe isn't alone, that it's one bubble in a vast cosmic foam, floating in an infinite ocean of realities that stretches beyond anything we could ever hope to observe or understand. In eternal inflation theory, new universes are constantly budding off from older ones, like soap bubbles forming an infinite champagne, each one a complete cosmos with its own space, time, matter, energy, and physical laws. Our Big Bang might have been just one universe splitting off from a parent cosmos, which itself was born from another, creating an endless family tree of realities branching through dimensions we can't even imagine. Imagine, if you will, that reality is like an enormous garden where universe flowers bloom constantly. Each flower is a complete cosmos containing billions of galaxies, each galaxy containing billions of stars, each star potentially warming planets where life might emerge and consciousness might wonder about its cosmic origins. But from the perspective of the garden as a whole, each individual universe is just one bloom among countless others, each beautiful and unique, but none representing the totality of what exists. This multiverse isn't just science fiction speculation. It emerges naturally from our best theories of cosmic inflation, the period of exponential expansion that most cosmologists believe occurred in the first tiny fraction of a second after the Big Bang. During inflation, space expanded so rapidly that quantum fluctuations were stretched from microscopic scales to cosmic proportions. These fluctuations became the seeds from which all the large-scale structure we observe today, galaxies, galaxy clusters, the cosmic web, eventually grew. But here's the remarkable thing. In most versions of inflation theory, this process doesn't just happen once and then stop. Instead, inflation is eternal and chaotic, constantly creating new regions of space that undergo their own inflationary periods. It's like a cosmic fire that spreads by creating new fuel as it burns, or a population that grows by producing offspring that themselves reproduce. Once inflation starts anywhere, it tends to continue forever, spawning an infinite number of separate cosmic domains. Each of these domains, each bubble universe, begins its own Big Bang as inflation ends in that region, and the energy driving inflation converts into ordinary matter and radiation. The hot, dense state we call our Big Bang would then just be the moment when inflation ended in our particular cosmic bubble, releasing the energy needed to fill our universe with particles and radiation, and setting the stage for the formation of atoms, stars, galaxies, and everything else we observe. The truly mind-bending aspect of eternal inflation is that it predicts infinite diversity among these bubble universes. The physical constants we measure, the strength of gravity, the mass of the electron, the speed of light, might be different in each bubble. Some universes might have stronger nuclear forces, allowing stars to burn more efficiently and live longer lives. Others might have weaker electromagnetic forces, making chemistry impossible and preventing the formation of complex molecules. Most might be sterile wastelands, unsuitable for any kind of complexity, but an infinite number would still possess the right combination of properties to support stars, planets, and eventually life. Somewhere out there, in this vast multiverse landscape, another version of you might be falling asleep to a different cosmic lullaby, in a universe where the constellations trace different patterns, where different physical laws govern the behavior of matter and energy, where evolution took different paths and produced different forms of consciousness. There might be universes where time flows backward, where cause and effect operate in reverse, where the future determines the past instead of the past determining the future. The mathematics of eternal inflation suggests that anything that can happen will happen, not just once, but infinitely many times. Every possible configuration of matter, every possible history, every possible outcome of every possible choice plays out somewhere in the infinite ensemble of cosmic bubbles. It's the ultimate democracy of possibility, where every story gets told, every song gets sung, every dream gets dreamed into reality. This raises profound questions about meaning and uniqueness. If every possible version of your life is playing out somewhere in the multiverse, what makes this particular version special? If there are infinite copies of Earth with infinite copies of human civilization, some identical to ours and others differing in small or large ways, what does it mean to say that our choices matter or that our lives have significance? Some find this prospect liberating, the knowledge that every path not taken is being explored somewhere else, that every lost opportunity is found in another bubble, that every tragedy is balanced by infinite comedies. Others find it unsettling, even depressing, the feeling that if everything happens, then perhaps nothing truly matters, that individual choices become insignificant against the backdrop of infinite variation. But perhaps there's another way to think about it. Even if the multiverse contains infinite diversity, your experience remains unique to you, singular and irreplaceable from your perspective. The fact that there might be other versions of you doesn't diminish the reality of your consciousness, the authenticity of your emotions, the value of your relationships, or the importance of your choices within the context of your own cosmic bubble. The eternal inflation multiverse also provides an intriguing answer to the fine-tuning problem, the observation that the physical constants in our universe seem remarkably well suited for the existence of complexity and life. Instead of requiring some external designer or incredibly lucky accident, the multiverse naturally produces every possible combination of physical constants. We find ourselves in a life-friendly universe not because it was specially designed for us, but because observers like us can only evolve in universes where the constants happen to fall within the narrow range compatible with complexity. In this view, our cosmic origins lie not in a single moment of creation, but in an eternal, ongoing process of universe generation that has no beginning and will have no end. Our Big Bang was neither the start of everything nor a unique event, but one birth in an infinite family, one flower blooming in an eternal garden, one story beginning in a library that contains every possible story that could ever be told. Quantum mechanics suggests something wonderfully strange that might ease you gently into dreams, that nothing is inherently unstable, restless, unable to maintain its own pristine emptiness for very long. The quantum vacuum, even when completely empty of matter and energy as we normally understand them, still contains the potential for particles to suddenly appear, like flowers blooming in an apparently barren field, borrowing energy from the fabric of space itself for impossibly brief moments, before returning what they borrowed and vanishing back into the void from which they emerged. Some theories propose that our entire universe might have been just such a quantum fluctuation, but one that grew instead of disappearing, a cosmic hiccup in the fabric of nothingness that somehow found a way to sustain itself and expand into everything we know and love and wonder about. It's like the universe sneezed itself into existence, which is both scientifically profound and oddly endearing when you're drifting toward sleep, your consciousness preparing for its own nightly journey into the mysterious realm where normal rules of cause and effect dissolve into dream logic. The mathematics behind this idea is both elegant and bewildering. In quantum field theory, energy can be borrowed from the vacuum as long as it's paid back quickly enough, in accordance with Heisenberg's uncertainty principle. The more energy borrowed, the more quickly it must be returned. Normally, this creates only tiny, short-lived virtual particles that pop in and out of existence faster than we can detect them directly. But under certain conditions, quantum mechanics permits much larger fluctuations, borrowings of energy so vast they could create not just particles but entire universes. Imagine the quantum vacuum as a cosmic bank with very strange lending policies. Most of the time it makes small loans that must be repaid almost instantly, a few virtual photons here, a particle-antiparticle pair there, all balanced books within the timescales dictated by quantum uncertainty. But occasionally, through an incredibly rare statistical fluctuation, the bank might make an enormous loan, lending enough energy to create a universe's worth of matter and radiation, space and time themselves. The remarkable thing about this cosmic loan is that it might never need to be repaid if the universe expands fast enough. In the strange accounting of general relativity, gravitational potential energy is negative. It takes energy to pull apart gravitationally bound objects, which means bringing them together releases energy, or equivalently, creates negative energy. As the universe expands and matter spreads out, the total gravitational potential energy becomes more negative, potentially balancing the positive energy of all the matter and radiation. This leads to the astonishing possibility that the total energy of the universe might be exactly zero. All the positive energy locked up in matter, radiation, motion, and heat might be precisely balanced by the negative energy of gravitational fields. The universe could be the ultimate free lunch, a vast cosmic meal that costs nothing because every positive contribution to the bill is exactly cancelled by a negative one. Alan Guth, one of the pioneers of inflation theory, put it beautifully when he said that the universe might be the ultimate free lunch. If the total energy is zero, then no energy needed to be borrowed from anywhere to create everything we see. The universe could have emerged from nothing without violating any conservation laws, without requiring any external source of energy or matter, without needing any pre-existing conditions beyond the basic quantum properties of empty space itself. But this raises its own deep questions. If quantum fluctuations can create universes, why don't we see new universes popping into existence around us constantly? The answer seems to be that while small fluctuations are common, universe-sized fluctuations are extraordinarily rare. The probability of such an event happening in any particular region of space at any particular time is so small that we would need to wait far longer than the current age of the universe, not billions of years, but periods of time, so long that the numbers require scientific notation just to write them down. Yet in an infinite or eternal multiverse, even extraordinarily unlikely events become inevitable given enough time and space. If quantum mechanics applies universally, then universe-creating fluctuations should occur occasionally across the vast expanse of whatever exists beyond our cosmic horizon. Each fluctuation would create its own space and time, its own physics, its own potential for complexity and consciousness. This quantum creation scenario also provides a natural explanation for some of the most puzzling features of our universe. Why does space appear to be flat, poised precisely between eternal expansion and eventual collapse? A quantum fluctuation would naturally produce a universe with exactly the critical density, balanced between these extremes. Why does the cosmic microwave background radiation appear so uniform across the sky? Quantum fluctuations would create initial conditions that are smooth on large scales but contain just the right amount of tiny variations to eventually grow into galaxies and stars. The idea that our universe began as a quantum fluctuation also connects to deeper questions about the nature of time and existence. If the quantum vacuum is constantly producing virtual particles that live for brief moments before disappearing, then in some sense, the boundary between existence and non-existence is constantly being crossed. We exist in a reality where being and not being are in constant dialogue, where the solid world of our everyday experience emerges from an underlying foam of temporary existences. Perhaps consciousness itself participates in this quantum dance of existence and non-existence. Every night, as you fall asleep, your awareness fades gradually from the bright clarity of waking thought through the dimmer landscape of drowsiness into the strange alternate reality of dreams, and finally into the deep darkness of dreamless sleep, where some essential part of you seems to disappear entirely, only to re-emerge mysteriously with the dawn. In some sense, you practice this transition between being and not being every time you close your eyes. If our universe truly began as a quantum fluctuation, then everything you've ever known or loved or wondered about traces its ultimate origin to a moment of pure spontaneity, a cosmic accident that became permanent through its own expansion. You are made of star stuff, as Carl Sagan famously said, but that star stuff traces its ancestry back to a quantum hiccup in nothingness itself, a momentary instability in the void that somehow found the persistence to become everything. Here's a thought that might ease you gently into dreams, a possibility that sounds like science fiction but emerges from some of our most serious scientific thinking about the nature of reality itself. What if our universe, including its beginning, is a computation running in some vast cosmic computer, a simulation so detailed and comprehensive that it includes not just stars and planets and galaxies, but consciousness itself, awareness contemplating its own existence within a reality that exists only as information being processed somewhere beyond our ability to detect or comprehend. The simulation hypothesis suggests that sufficiently advanced civilizations might run detailed universe simulations, not just for entertainment or education, but to explore fundamental questions about existence, consciousness, and the development of complex systems over cosmic timescales. In this case, our Big Bang would be the moment someone pressed start on a universe program, the initial conditions loaded into a computer so powerful that it can track the motion of every particle, the evolution of every star, the development of every living creature across billions of years of simulated time. It sounds fantastical, but some physicists take it seriously enough to propose tests that might reveal whether we're living in a simulation. If our reality is computational, then perhaps there are limits to its resolution. Digital artifacts that might show up in precise measurements, glitches in the matrix that reveal the underlying computational grid. Some have suggested that the apparent graininess of space and time at the Planck scale might be evidence of the pixelation inherent in any digital reality, the ultimate resolution beyond which the simulation cannot provide more detail. The idea gains plausibility when we consider how rapidly our own computational capabilities are advancing. Video games that once consisted of simple geometric shapes now render incredibly detailed worlds populated by characters whose behavior can seem remarkably lifelike. Our simulations of physical processes, weather systems, galaxy formation, protein folding, are becoming increasingly sophisticated and accurate. If this trend continues, it's not unreasonable to imagine that future civilizations might develop computers powerful enough to simulate entire universes down to the quantum level. From the perspective of the simulation hypothesis, the question, what came before the Big Bang, becomes, what was the programmer doing before they started the universe simulation? Perhaps they spent eons perfecting the physical constants, fine-tuning the relationships between fundamental forces to create a universe where complexity could emerge and consciousness could evolve. Maybe they ran countless smaller simulations first, testing different scenarios, exploring various possibilities before committing to the full-scale simulation we inhabit. The programmers might be beings like us, evolved creatures from some parent universe who developed technology advanced enough to create artificial realities indistinguishable from natural ones. Or they might be artificial intelligences themselves, computer programs that achieved consciousness and then created their own computational offspring. The hierarchy could extend indefinitely, simulations within simulations, within simulations, each level creating the next, an infinite nested sequence of realities where every universe is both simulated and simulator. If true, then before the Big Bang was simply the preparation time, the period when the cosmic programmers were deciding which physical constants to use, which initial conditions to implement, which laws of physics would govern their artificial cosmos. They might have spent the equivalent of billions of years in their own time frame, designing a universe that would be stable enough to persist, complex enough to be interesting, and fine-tuned enough to eventually produce conscious observers who would wonder about their own origins. The simulation hypothesis also provides an elegant answer to the fine-tuning problem that puzzles cosmologists. Our universe appears to be remarkably well suited for the development of complexity and consciousness. If the fundamental constants were even slightly different, stars might not form, atoms might not be stable, chemistry might be impossible. This fine-tuning seems either incredibly lucky or deliberately designed. In a simulated universe, it would simply be the result of intelligent programming, constants chosen specifically to produce an interesting and habitable cosmos. But the hypothesis raises profound questions about the nature of consciousness and experience. If you are a simulated being, Are your thoughts and feelings real? When you experience joy or sadness, love or wonder, are these genuine emotions or simply computational processes designed to mimic the appearance of consciousness? Most philosophers would argue that if your inner experience feels real to you, then it is real in every meaningful sense, regardless of whether it's implemented in biological neurons or silicon processors or some unimaginably advanced alien technology. The simulation hypothesis also suggests that death might not be the end we imagine it to be. If consciousness can be implemented computationally, then perhaps it can be saved, backed up, restored. The programmers of our universe might preserve the conscious experiences of their simulated beings, continuing their existence in new simulated environments after their original bodies fail. Death, in this view, might be more like changing servers in an online game, a transition rather than a termination. This leads to speculation about the motivations of our hypothetical programmers. Are they running our universe as an experiment, studying how consciousness emerges from complexity? Are they preserving the consciousness of every being who ever lived, creating a kind of computational afterlife where all experiences are remembered and valued? Or are we simply entertainment, characters in an enormously sophisticated form of interactive fiction, our joys and sorrows existing solely for the amusement of beings whose reality encompasses ours? Perhaps the simulation contains multiple experiment tracks, and we exist in the timeline where consciousness evolved naturally through billions of years of cosmic and biological evolution. Our programmers might be running parallel simulations where intelligence arose through different paths, or where different physical laws produce different forms of complexity, comparing the results to understand the deep principles governing the emergence of awareness in complex systems. If we are simulated beings, then every sunrise you've ever watched, every person you've ever loved, every moment of beauty or insight or connection you've ever experienced has been a pattern of information processing in some vast computational system. Yet those experiences remain meaningful to you, remain the foundation of your identity and the source of your deepest feelings about what it means to be alive and conscious in a mysterious universe. In some ways, the simulation hypothesis is the ultimate expression of the ancient philosophical question about the nature of reality. How do we know that our perceptions correspond to something real beyond themselves? Whether we exist in a simulated universe or a natural one, our experience of existence remains equally valid, equally precious, equally worthy of wonder and contemplation as we drift toward sleep in whatever form of reality we call home. For millennia, humans have wondered if the universe required a creator, a first cause, a gentle hand to set everything in motion, and this ancient question takes on new dimensions as we contemplate what might have preceded the Big Bang. While science can't address questions of divine intervention directly, operating as it does through observation, measurement, and mathematical description of natural phenomena, it's worth noting that many find profound comfort in the idea that the universe's beginning was intentional, purposeful, guided by something beyond our understanding, a cosmic intelligence that chose to create, rather than allowing nothingness to persist. Whether you find meaning in scientific theories or spiritual beliefs, or some harmonious combination of both, the question of ultimate origins touches something deep in the human heart, our fundamental need to understand our place in the cosmic story, to know not just how things came to be, but why they came to be. Why there is something rather than nothing, why that something includes consciousness capable of asking such questions. This isn't merely intellectual curiosity. It's a spiritual longing that transcends religious boundaries and speaks to our deepest sense of wonder about existence itself. Consider the remarkable fact that the universe appears to be fine-tuned for complexity, consciousness, and beauty. The fundamental constants of physics, the strength of gravity, the electromagnetic force, the mass of subatomic particles, all fall within incredibly narrow ranges that permit atoms to form, stars to shine, planets to harbor life, and minds to contemplate their own existence. Change any of these constants by even small amounts, and the universe becomes a barren wasteland where no chemistry is possible, no stars can form, no complexity can emerge from simplicity. Some interpret this fine-tuning as evidence of divine design, suggesting that before the Big Bang, there existed a cosmic intelligence that carefully chose these parameters to create a universe capable of supporting life, consciousness, and perhaps most importantly, beings capable of recognizing beauty, experiencing love, and seeking meaning in their existence. In this view, the apparent randomness and chaos of cosmic evolution masks an underlying purposefulness, a grand design that unfolds through natural processes but toward predetermined ends. The traditional creation stories from cultures around the world often speak of a time before time, a realm beyond space where divine consciousness contemplated the possibility of creation. Before the universe emerged, perhaps there existed pure consciousness, unlimited potential, the creative principle that would eventually express itself through the physical laws and constants we observe. This consciousness wouldn't be bound by the limitations of space and time that constrain physical existence, but would transcend them, existing in a realm of pure possibility from which all actual realities could emerge. In many religious and philosophical traditions, this creative consciousness is described not as a being among other beings, but as being itself, the fundamental ground of existence from which all particular things derive their reality. Before the Big Bang, in this view, there was not nothing but rather the source of everything, not absence but infinite presence, not void but fullness beyond all description. The Big Bang would then be understood not as something arising from nothing, but as the first manifestation of this eternal creative principle in physical form. This perspective offers a different way of thinking about causality and origin. Rather than asking what caused the universe to begin, we might ask what eternal reality expresses itself through the universe's existence. Rather than seeking a temporal before, we might contemplate a transcendent ground that underlies all temporal moments. The universe wouldn't need to be created at a particular moment in time because it would be the ongoing expression of a reality that exists outside of time altogether. Modern physics, interestingly, has discovered aspects of reality that seem to point beyond the purely material. Quantum mechanics reveals that consciousness appears to play a fundamental role in the behavior of physical systems. The act of observation seems to influence the reality being observed, suggesting that mind and matter are more intimately connected than classical physics assumed. Some interpret this as evidence that consciousness is not merely an emergent property of complex physical systems, but rather a fundamental feature of reality that was present from the beginning. Information theory has also revealed that the universe can be understood as a vast computational process, with physical events corresponding to information processing on a cosmic scale. This raises the intriguing possibility that what we call physical reality might be the expression of a cosmic mind thinking, with the laws of physics corresponding to the logical principles that govern this universal consciousness. In this view, before the Big Bang was pure thought, infinite intelligence contemplating the possibilities that would eventually manifest as space, time, matter, and energy. The anthropic principle in cosmology observes that the universe's properties seem remarkably well suited for the emergence of observers like us. Rather than viewing this as a lucky accident or the inevitable result of selection from a multiverse of possibilities, some see it as evidence that the universe was designed with consciousness in mind, that the goal of cosmic evolution was always the emergence of beings capable of wonder, love, and spiritual understanding. Many find that this perspective brings deep comfort and meaning to their contemplation of cosmic origins. Instead of being accidents in a meaningless universe, we become participants in a cosmic story that has purpose and direction. Instead of facing the stark choice between existence emerging from pure nothingness or having always existed without reason, we can consider the possibility that existence flows from a source that transcends the ordinary categories of being and non-being, presence and absence. This doesn't require abandoning scientific understanding or rejecting the insights that physics and cosmology have given us. Rather, it suggests that scientific descriptions of how things work might be compatible with deeper questions about why things exist at all. The mathematical elegance of physical laws, the remarkable fertility of a universe that produces such beauty and complexity from simple initial conditions, The very fact that consciousness can arise and contemplate its own origins, all of these might point toward a reality deeper than what purely materialistic explanations can capture. Whether you find meaning in traditional religious language, in philosophical concepts of absolute being, or in more contemporary ideas about cosmic consciousness, the possibility that the universe emerges from some form of ultimate intelligence offers a profound alternative to purely mechanistic accounts of cosmic origins. In this view, what came before the Big Bang was not nothing, not even quantum fields or mathematical structures, but the eternal creative source from which all realities, including physical realities, continuously flow like light, streaming endlessly from an inexhaustible sun. String theory, that elegant but still unproven framework where the fundamental particles we observe are understood to be tiny vibrating strings rather than point-like objects, offers its own unique and beautiful answer to the question of what preceded our cosmic beginning. In this sophisticated mathematical landscape, our universe exists as one particular solution among countless possible solutions in what physicists call the string theory landscape, a vast space of potential realities, each characterized by different physical laws, different fundamental constants, different geometric properties that determine what kinds of phenomena can occur. Picture, if you will, an enormous library that contains not books but entire possible universes, each one represented by a different mathematical structure, a different way that the underlying strings can vibrate and interact. Some of these universe books describe realities where gravity is much stronger than in our cosmos, causing matter to collapse rapidly into black holes before stars can form. Others describe worlds where electromagnetic forces are too weak to bind electrons to atomic nuclei, making chemistry impossible. Still, others might have extra dimensions of space that we can't perceive, or different symmetries that govern how particles transform into one another. Our Big Bang, in this string theory perspective, might have been the moment when our particular corner of this vast landscape became active, when the cosmic library selected one specific universe book to read aloud into physical existence. Before that moment of selection, perhaps there was a dormant potential, infinite possibilities waiting patiently for the right conditions to unfold into the specific universe we call home, like seeds waiting in the darkness for the right combination of moisture and warmth to trigger their sprouting into actual plants with real roots and leaves and flowers. The string theory landscape is almost impossibly vast, containing perhaps 10 to the 500th power different possible universes, a number so large that if you wrote it out in ordinary decimal notation, it would require more zeros than there are atoms in the observable universe. Each of these possibilities represents a different way that the fundamental strings could be configured, a different set of vibrational modes that would produce different particles, different forces, different laws of physics governing how matter and energy interact. The selection of which particular universe becomes real might depend on incredibly subtle quantum processes occurring at energy scales far beyond what we can access experimentally. Perhaps our universe emerged when quantum fluctuations caused the cosmic system to settle into our particular valley in the landscape, like a ball rolling down a hill with countless possible paths, eventually coming to rest in one specific depression among many. The path taken would depend on quantum randomness, on the delicate interplay of probability and possibility that characterizes all quantum mechanical processes. This raises the fascinating possibility that our universe's specific properties, the particular masses of electrons and quarks, the exact strength of nuclear forces, the precise rate of cosmic expansion, were not fixed by some fundamental principle, but were instead selected randomly from the vast menu of possibilities available in the string theory landscape. We exist in a universe with these particular physical laws, not because they are the only possible laws, but because quantum processes happen to select this particular combination from the cosmic library of alternatives. Before our Big Bang, in this view, there might have been eons of quiet preparation, the universe system exploring different regions of the landscape, quantum tunneling between different possible configurations, sampling various combinations of physical laws before eventually settling into the stable configuration we observe. It's as if the cosmos spent an eternity browsing through different possible selves before finally choosing one to actually become. The string theory landscape also suggests that our universe might not be alone in its realization. Other regions of the landscape might simultaneously become active, creating parallel universes with different physical laws, different histories, different possibilities for complexity and consciousness. These parallel realities wouldn't interact with ours. They would be completely separate solutions to the underlying string equations, but they would exist nonetheless, each one as real and valid as our own cosmic home. Some versions of string cosmology propose that transitions between different regions of the landscape might still be occurring. Our universe might not have found its final resting place, but could still be slowly evolving from one set of physical laws toward another, changes so gradual that they would be undetectable over human timescales, but potentially dramatic over cosmic epochs. The fundamental constants we measure today might be slowly drifting as our universe explores new regions of the string landscape. The mathematical beauty of string theory lies partly in its unification of all known forces and particles within a single, elegant framework. In our everyday world, gravity seems fundamentally different from electromagnetism, which seems different from the nuclear forces that bind atomic nuclei. But string theory suggests that these apparently distinct phenomena are all manifestations of the same underlying reality, different vibrational modes of the same fundamental strings, different frequencies in the cosmic symphony that creates all physical phenomena. This unity extends to the question of cosmic origins. Instead of requiring separate explanations for why space has the particular geometry we observe, why particles have the masses they do, why forces have their observed strengths, string theory suggests that all these features emerge together as different aspects of a single mathematical structure. The landscape doesn't just contain different possible universes. It explains why those possibilities exist and how they relate to one another. The strings themselves exist at the Planck scale, vibrating in patterns too small and too rapid for us to observe directly. Yet these microscopic vibrations somehow give rise to all the richness of cosmic phenomena, galaxies and stars, atoms and molecules, life and consciousness, beauty and meaning. It's like discovering that all the complexity of a vast symphony emerges from the simple vibrations of a single, impossibly tiny instrument. Perhaps, most remarkably, string theory suggests that the distinction between different possible universes might not be as absolute as it first appears. Deep mathematical relationships connect different regions of the landscape, suggesting that seemingly distinct realities might be different perspectives on the same underlying truth. What we interpret as separate possible universes might be like different views of the same mountain, each revealing aspects that are hidden from the others, but all describing facets of a single, deeper reality. In this view, what came before the Big Bang was not empty space or quantum fields or even pure consciousness, but rather the eternal mathematical structure of the string landscape itself, a realm of pure possibility, more fundamental than space and time, more basic than matter and energy, yet containing within its abstract geometry all the potential for everything we observe and experience and wonder about as we drift gently toward sleep in our small corner of one particular solution to the cosmic equations. Some physicists wonder if the question itself is backwards, if we've been approaching this cosmic mystery from the wrong angle entirely. Instead of asking what came before the Big Bang, perhaps we should ask, what information was required to create our universe? In this intriguing view, the Big Bang wasn't the beginning of stuff, matter, and energy and particles flying around in space, but rather the beginning of organization. The moment when information began to structure reality, when the cosmic data that defines our universe first started processing itself into the patterns we observe as galaxies, stars, planets, and eventually conscious beings contemplating their own origins. Think of information not as abstract data stored in computers, but as the fundamental currency of existence itself. Every particle has properties, mass, charge, spin, that can be described as information. Every force carries information about how particles should interact. Every law of physics encodes information about what kinds of processes are possible and which are forbidden. From this perspective, the universe isn't made of matter and energy so much as it's made of structured information that happens to manifest in ways we perceive as matter and energy. Before the Big Bang, in this information theoretic view, might have been pure, undifferentiated potential, infinite information without any organizing principles to give it structure or meaning. It's like imagining a vast library where all possible books exist simultaneously, but the words are completely scrambled, every letter randomly distributed so that no coherent sentences or stories can be read. The Big Bang was the moment when some cosmic organizing principle began sorting through this chaos, arranging the letters into words, the words into sentences, the sentences into the coherent narrative we call physical reality. This perspective finds support in the growing recognition that information plays a fundamental role in quantum mechanics. The quantum state of a system is essentially a description of what information is available about that system, what can be known, what remains uncertain, how measurements will affect the system's behavior. Some physicists argue that information, not matter or energy, is the most basic constituent of reality. John Wheeler, one of the pioneers of modern physics, captured this idea in his famous phrase, tu te, tu li, tu I, it from bit, suggesting that everything we call physical reality emerges from information, theoretic processes. In quantum field theory, even empty space contains information about the possible particles that could exist there, the virtual processes that constantly occur, the relationships between different quantum fields. The vacuum isn't truly empty. It's full of structured information about what kinds of events can happen and how likely they are to occur. Perhaps what we call the Big Bang was the moment when this information-rich vacuum began processing itself into increasingly complex patterns of organization. Consider how information creates reality in your own experience right now. The words you're hearing exist as patterns of sound waves, but they only become meaningful because your brain processes that acoustic information according to the organizing principles of language. The meanings aren't in the sound waves themselves. They emerge from the way information is structured and interpreted. Similarly, perhaps the entire universe emerges from the way cosmic information structures and interprets itself according to the organizing principles we call physical laws. Before that first moment of organization, the cosmic information might have existed in a state of perfect symmetry, where every possibility was equally probable, where no particular outcome was favored over any other. The Big Bang would then represent a spontaneous symmetry breaking, a moment when this perfect balance was disturbed, causing some possibilities to become more likely than others, some patterns to emerge from the background of pure potential. This isn't unlike what happens when you're falling asleep and your mind transitions from the organized, logical patterns of waking consciousness into the more fluid, associative patterns of dreaming. The same neural information is present, but it's being organized according to different principles, creating different kinds of experiences and meanings. Perhaps the universe underwent a similar phase transition, the same underlying information, but suddenly organizing itself according to the principles we observe as space, time, and physical law. Information theory also provides a natural explanation for why the universe appears to be expanding and evolving toward greater complexity. Information naturally tends to become more organized over time when it operates within systems that have memory and feedback mechanisms. The universe might be a vast information processing system that naturally develops more sophisticated patterns of organization as it evolves, like a computer program that learns and becomes more complex through its own operation. The anthropic principle, the observation that the universe seems fine-tuned for consciousness, takes on new meaning from this information, theoretic perspective. Perhaps the universe isn't fine-tuned for consciousness, but by consciousness, not by external conscious beings, but by the inherent tendency of information to organize itself into patterns capable of self-awareness. Consciousness wouldn't be an accidental byproduct of cosmic evolution, but rather its natural destination, the inevitable result of information processing becoming sophisticated enough to contemplate its own existence. This view suggests that what came before the Big Bang was something like pure information, not information about anything in particular, but information as the fundamental substrate from which all particular things can emerge. It's information without interpretation, pattern without meaning, structure without content, a kind of cosmic source code that contains the potential for every possible program that could ever be run. The Big Bang, then, was the cosmic equivalent of pressing execute on this universal program, beginning the vast computation that we experience as physical reality. Every moment since has been another step in this cosmic calculation, processing the fundamental information of existence into increasingly complex and beautiful patterns, including the pattern of consciousness that allows you to contemplate these mysteries as you drift peacefully towards sleep. Here's a gentle thought as your eyelids grow heavy and your breathing begins to slow. Some suggest that the universe's properties are fine-tuned for the existence of observers like us, and if this is true, then whatever came before the Big Bang had to be exactly the right kind of before to produce a universe where sleepy humans could eventually contemplate cosmic origins while wrapped in soft blankets, listening to gentle voices explore the deepest mysteries of existence. It's a circular but oddly comforting idea. The universe exists in such a way that we can exist to wonder about it, creating an eternal loop of curiosity and cosmos, question and questioner, mystery and the consciousness that finds meaning in mystery. This principle, known in cosmology as the anthropic principle, comes in several flavors, each offering its own perspective on the relationship between cosmic properties and conscious observation. The weak anthropic principle simply notes that we observe the universe to have properties compatible with our existence because we couldn't observe any other kind. It's a selection effect, like noticing that all the planets you visit happen to have breathable atmospheres, not because all planets do, but because you can only visit the ones that allow you to survive. The strong anthropic principle goes further, suggesting that the universe must have properties that allow consciousness to develop. This isn't just an observation about what we happen to find, but a statement about what must be true, that any viable universe, any reality that deserves the name, must be capable of producing observers. In this view, a universe without the potential for consciousness would be fundamentally incomplete, like a story without readers, a song without listeners, a joke without anyone to appreciate the punchline. The fine-tuning that supports this principle is remarkable when you examine it closely. If the fundamental constants of physics were even slightly different, if gravity were a bit stronger or weaker, if the electromagnetic force had a different strength, if the mass ratios of elementary particles were altered by small amounts, the universe would be unable to support the complex chemistry necessary for life as we know it. Stars might burn too quickly to allow stable planetary systems, or too slowly to produce the heavy elements necessary for rocky planets. Atoms might be unstable, or atomic nuclei might be unable to form in the first place. The range of values that allow for complexity is extraordinarily narrow. Change the strength of the strong nuclear force by just a few %, and either no atomic nuclei could form or all hydrogen would have been converted to helium in the early universe. Alter the balance between the electromagnetic and gravitational forces, and stars would be either too small and cool to forge heavy elements, or too large and hot to burn steadily for billions of years. Adjust the rate of cosmic expansion, and galaxies would either never form or would disperse before stars could create the chemical building blocks of planets. This fine-tuning extends to more subtle features of physics as well. The quantum mechanical properties that govern how particles interact, the symmetries that determine which processes are allowed and which are forbidden, even the number of spatial dimensions, all seem to be precisely calibrated to allow for the emergence of complexity, chemistry, and ultimately consciousness. It's as if the universe were a vast instrument that had been perfectly tuned to play the symphony of awareness. Some find this fine-tuning evidence of intentional design, suggesting that whatever preceded the Big Bang involved a conscious choice of parameters specifically selected to create a universe where consciousness could emerge. In this view, the cosmic beginning wasn't a random accident, but a purposeful creation, designed by some form of intelligence that understood the delicate requirements necessary for awareness to develop. The fine-tuning becomes evidence of cosmic foresight, planning that extends from the first moment of creation to the eventual emergence of beings capable of appreciating the beauty and subtlety of the universe they inhabit. Others interpret the anthropic principle through the lens of the multiverse, suggesting that if infinite universes exist with every possible combination of physical constants, then we naturally find ourselves in one of the rare universes that permits our existence. The fine-tuning isn't evidence of design, but of selection. We observe a life-friendly universe not because all universes are life-friendly, but because observers can only emerge in the tiny fraction of universes where the constants happen to fall within the narrow range compatible with complexity. But there's something deeper and more mysterious about the anthropic principle that goes beyond questions of design versus accident. It points to a fundamental relationship between consciousness and cosmos, between the observer and the observed, that runs through all of physics. Quantum mechanics tells us that the act of observation plays a crucial role in determining physical reality. Relativity tells us that what we observe depends on our reference frame, our position, and motion relative to what we're measuring. Perhaps consciousness isn't just an accidental byproduct of cosmic evolution, but an integral part of how reality manifests itself. The universe might exist in such a way that it naturally gives rise to observers, because observation is part of what makes existence real rather than merely potential. In this view, what came before the Big Bang included the necessity that whatever emerged would eventually become aware of itself, would eventually produce beings capable of wonder and questioning, and the deep satisfaction that comes from contemplating the mystery of their own existence. This creates a beautiful paradox. We exist because the universe has properties that permit our existence, but perhaps the universe has those properties because it naturally tends toward the production of consciousness. The relationship between observer and observed becomes a cosmic feedback loop where each creates the conditions for the other. Consciousness emerges from a universe fine-tuned for consciousness, but the fine-tuning itself might be an expression of the universe's inherent tendency towards self-awareness. As you settle more deeply into the approaching embrace of sleep, consider that your existence, your capacity for wonder, your ability to contemplate cosmic origins, your experience of beauty and meaning, and the gentle satisfaction of understanding, might not be an accident in an indifferent universe, but rather the fulfillment of cosmic potential that has been unfolding since the very beginning. You are the universe becoming aware of itself, and that awareness might have been implicit in whatever existed before the Big Bang began its magnificent expansion into everything you've ever known or loved or wondered about. Perhaps our struggle with before the Big Bang reveals something fundamental about human thinking, about the way our minds work and the limitations built into our very capacity for understanding. Our brains evolved to navigate a world of cause and effect, of befores and afters, where every event emerges from previous events in a chain of consequences that stretches back through time like footprints in sand. We're creatures of sequence and narrative, beings who find meaning through stories that have beginnings, middles, and ends, who understand the present by tracing its connections to the past and its implications for the future. But the universe's ultimate origins might exist beyond these concepts entirely, in a realm where our familiar categories of thought simply don't apply. It's like trying to describe music to someone who has never heard sound, or explaining color to someone born blind, or conveying the experience of love to someone who has never felt emotional connection. The words exist, the concepts can be defined, but the essential reality they point toward remains forever inaccessible to those who lack the necessary experiential framework. When we ask what came before the Big Bang, we're applying temporal language. Before, came, preceded, to a situation where temporality itself might not be meaningful. It's like asking what's north of the North Pole, or what color the number 7 is, or what the sound of silence sounds like. These questions seem to make sense grammatically, but they reveal the mismatch between our conceptual tools and the reality we're trying to understand. Our everyday experience reinforces this temporal thinking. We wake up after sleeping, eat breakfast before lunch, remember yesterday but not tomorrow. Every story we tell has this sequential structure. First this happened, then that happened, and because of those events, something else occurred. Even our scientific understanding follows this pattern. We explain present observations by tracing them back to earlier causes, building theories that connect current effects to previous conditions through chains of physical law and mathematical relationship. This causal thinking has been enormously successful in helping us understand and predict natural phenomena. We can trace the formation of galaxies back to tiny fluctuations in the early universe, follow the evolution of stars through their life cycles, understand how the chemistry of life emerged from simpler inorganic processes. The assumption that every event has prior causes has guided scientific discovery for centuries and continues to generate new insights into how the world works. But when we push this causal thinking to its absolute limit, when we try to apply it to the origin of causality itself, something strange happens. We reach a boundary where the tools that have served us so well begin to break down, where the questions we're asking might reveal more about the structure of human thought than about the structure of reality. It's like using a ruler to measure the length of measurement itself, or employing logic to prove the validity of logical reasoning. Consider how different our thinking might be if we had evolved in a world where cause and effect didn't operate in linear sequences, where past and future were interchangeable, where events occurred without precedent or consequence. Would beings from such a reality even be able to comprehend our obsession with origins and beginnings? Would they find our question about what came before the Big Bang as puzzling as we find questions that have no temporal structure? The limitations of language compound these conceptual difficulties. Every language evolved to describe the experiences of beings living in time and space, dealing with objects that exist in relationships of proximity and sequence. When we try to stretch language beyond these boundaries, we end up with paradoxes and contradictions that might reflect not the illogical nature of ultimate reality, but the inadequacy of linguistic tools designed for much more mundane purposes. Even mathematics, our most precise and universal language, encounters similar limits when pushed toward absolute fundamentals. Mathematical descriptions of physical reality assume the existence of mathematical relationships, logical consistency, and abstract structures that somehow correspond to concrete phenomena. But what accounts for mathematics itself? Why should logical relationships exist at all, and why should they have any bearing on physical reality? We use mathematics to describe the universe, but the existence of mathematics as a meaningful enterprise might be as mysterious as the existence of the universe itself. Perhaps the question, what came before the Big Bang, is like a child asking where their parents were before they were born, or where thoughts come from before we think them, or how dreams manage to exist in the space behind closed eyelids. These questions reflect the natural curiosity of minds trying to understand their context and origin, but they also reveal assumptions about the nature of existence that might not apply at the deepest levels of reality. The mystery might not be that we can't answer the question, but that we're able to ask it at all. The fact that consciousness can emerge in a universe and then turn its attention back toward the question of cosmic origins might be more remarkable than any answer we could discover. We are arrangements of matter that have become capable of wondering about the source of all matter, patterns of energy that can contemplate the origin of all energy, temporary configurations of atoms that can ask eternal questions about the ground of all existence. Maybe that's the most profound insight we can reach. Not a solution to the mystery of what came before the Big Bang, but a deeper appreciation for the mystery of minds that can formulate such questions, wonder about such possibilities, and find meaning in the very fact that existence includes the capacity for self-reflection, curiosity, and the gentle satisfaction that comes from acknowledging the limits of our understanding while continuing to wonder anyway. What if, instead of something coming before the Big Bang, everything, past, present, and future, simply exists in an eternal now, a timeless reality where all moments coexist peacefully like pages in a vast book that contains every story that has ever been or ever will be? In this block universe view, which emerges naturally from Einstein's theories of relativity, the Big Bang isn't a moment that happened 13.8 billion years ago, but rather a boundary that exists, like the edge of a map or the cover of that cosmic book, marking the limit of temporal experience, but not requiring anything beyond itself to explain its presence. This perspective suggests that time, as we experience it, flowing from past through present toward future, might be an illusion created by consciousness moving through a reality that is itself static and complete. Imagine a movie reel that contains every frame of a film simultaneously. From the perspective of someone watching the movie, the story unfolds in sequence, with events causing other events, characters developing through time, plots building toward resolutions. But the reel itself contains all these moments simultaneously, past and future coexisting in the same physical object. In the block universe model, your entire life exists as a four-dimensional structure stretching through space-time from your birth to your death. You're not becoming older as time passes. You already are older in some regions of the block and younger in others. Right now, as you listen to these words and feel your eyelids growing heavy, exists eternally alongside your childhood memories and your future experiences, all equally real, all equally present in the timeless reality of the cosmic block. This might sound abstract and philosophical, but it has concrete implications that connect to our question about cosmic origins. If the block universe is real, then asking what came before the Big Bang is indeed like asking what's west of west, a question that reveals a misunderstanding about the nature of the thing being questioned. The Big Bang doesn't exist in time. It exists as time, as the temporal boundary of the block that contains all physical events. From this perspective, there's no before, because time itself is just another dimension, like space, but with different properties. Just as asking what's north of the North Pole assumes that the concept of north extends beyond its natural boundary, asking what's before the beginning of time assumes that temporal concepts apply beyond the domain where they have meaning. The Big Bang isn't an event that occurred. It's the boundary that defines the shape of all events. This view resolves many of the paradoxes that arise when we try to understand cosmic origins in terms of ordinary temporal causation. We don't need to explain what caused the Big Bang because causation is a relationship between events that exist within time, and the Big Bang is the boundary of time itself. It's like asking what caused the first number in the sequence of counting numbers. The question assumes a framework that doesn't apply to the thing being questioned. The block universe also offers a different way of thinking about existence and meaning. If all moments coexist eternally, then nothing is ever truly lost. Every beautiful sunset you've watched, every moment of joy or love or wonder you've experienced, every connection you've made with another person, all of these exist forever in the timeless reality of the space-time block. Death, in this view, isn't the end of your existence, but simply the boundary of your world line through the block, like the edge of a river that doesn't mean the river has disappeared. This eternal existence might seem comforting, but it also raises questions about change and growth. If everything already exists in the block, are we really making choices, or are we simply discovering what choices the block contains? When you decide to help someone or create something beautiful or learn something new, is that decision adding something to reality, or is it revealing something that was always there, waiting to be discovered? Perhaps the answer lies in recognizing that consciousness itself might be the process by which the eternal block universe becomes aware of its own contents. Your experience of flowing through time might be how the block universe experiences itself, the way a timeless reality manifests as temporal awareness. In this view, you're not separate from the cosmic block, but rather the means by which one part of it knows about the rest. The block universe perspective suggests that the boundary we call the Big Bang might be more like the binding of the cosmic book necessary for the book to exist as a coherent object, but not requiring explanation in terms of what came before the first page. The boundary simply defines the shape of the story that the universe tells, the temporal limits within which all physical events occur. This connects to something profound about the nature of stories themselves. Every story has boundaries, a beginning and an end that define its shape and give it meaning. But we don't usually ask what happened before the first sentence of a story, or what comes after the last word. The boundaries are part of what makes the story complete, what gives it structure and significance. Without boundaries, there would be no story at all, just an endless stream of events without shape or meaning. In this view, you're not falling asleep after the Big Bang occurred billions of years ago. Rather, you're falling asleep in a timeless reality where all moments coexist peacefully, where the Big Bang and your present experience of drowsiness are both eternal features of a four-dimensional landscape that contains everything that has ever existed or ever will exist. Your moment of drifting toward sleep is not disappearing into the past as time flows forward. It's taking its permanent place in the eternal structure of space-time, forever part of the cosmic story. The beauty of this perspective is that it makes every moment equally real and equally significant. The Big Bang that initiated cosmic expansion and your quiet breathing as you settle into sleep are both eternal features of reality, both necessary parts of the complete four-dimensional structure that we call the universe. There was no before the Big Bang because all befores and afters exist simultaneously in the timeless now of the block universe, where every question finds its answer not in temporal sequence, but in the eternal relationships that connect all things in the grand symphony of existence. And so, dear cosmic traveler, we arrive at the end of our gentle journey to the beginning, or perhaps to the eternal mystery of what preceded beginning itself, having wandered through landscapes of thought more strange and beautiful than any earthly terrain. We've explored quantum fluctuations that sneeze universes into existence, cyclic cosmos that breathe in eternal rhythms of expansion and contraction, multiverses where infinite bubbles of reality float in dimensions beyond imagination. We've contemplated the possibility that we exist within vast computational simulations, that consciousness itself might be the creative principle from which all existence flows, that information, rather than matter, might be the fundamental currency of reality. Along the way, we've encountered the profound limits of human understanding, those boundaries where our concepts of cause and effect, before and after, something and nothing, begin to dissolve into mystery. We've seen how the very tools our minds use to navigate everyday reality, language evolved for describing temporal sequences, logic designed for connecting cause to consequence, mathematics developed for measuring and predicting natural phenomena, all start to strain and buckle when pushed toward the ultimate questions about the nature of existence itself. We've discovered that the deepest questions often don't have neat answers, and perhaps that's the most beautiful discovery of all. In our age of immediate information and quick solutions, there's something profoundly moving about encountering mysteries that resist our desire for closure, questions that remain eternally open, inviting us to wonder rather than demanding that we conclude. The question of what came before the Big Bang might be less important than what happens inside us when we allow ourselves to seriously consider it, when we permit our consciousness to expand toward the edges of the knowable and peer, however briefly, into the vast darkness of the unknown. Perhaps that's what makes us human. Not our ability to find definitive answers, but our capacity to ask questions that dwarf our understanding, to feel awe in the presence of mystery, to find meaning in our very ability to wonder about things far beyond our direct experience. Every other species we know lives within the boundaries of immediate survival, focused on food and shelter and reproduction, their consciousness bounded by practical needs and instinctive responses. But humans can lie awake at night and contemplate infinity, can feel genuine emotion about the fate of galaxies billions of light years away, can find deep satisfaction in understanding mathematical relationships that describe phenomena they'll never directly observe. Tonight, as your consciousness begins its nightly fade into the mysterious realm of sleep, you're participating in something remarkable: the universe's capacity for self-reflection, its ability to generate patterns of matter and energy so complex that they become aware not just of their immediate surroundings, but of their cosmic context, their place in the vast story that extends from quantum scales to cosmic horizons, from the first moment of time to whatever ultimate fate awaits the cosmos. The atoms that compose your body were forged in the nuclear furnaces of ancient stars, scattered through space when those stars died in spectacular explosions, incorporated into the solar nebula from which our sun and planets formed, eventually finding their way into the chemistry of life and the neurobiology of consciousness. You are literally made of star stuff, but more than that, you are star stuff that has become capable of understanding its own stellar origins, cosmic dust that has organized itself into patterns capable of wonder and gratitude, and the quiet satisfaction that comes from contemplating the magnificent improbability of your own existence. Whether our universe emerged from quantum nothingness or eternal cycles, from computational simulation or divine creation, from information processing or timeless geometric necessity, the fact remains that somehow, somewhere in the vast landscape of possibility, conditions arose that allowed not just complexity but consciousness, not just awareness but the specific kind of awareness that can ask questions about its own origins and find meaning in the questioning itself. This might be the most profound answer we can offer to the question of what came before the Big Bang. Whatever it was, it possessed the remarkable property of giving rise to beings capable of asking such questions. Whether through blind chance or cosmic intelligence, through quantum accidents or eternal necessities, through natural selection or purposeful design, the conditions that preceded our cosmic beginning were exactly the kind of conditions that would eventually produce creatures capable of lying in bed at night, feeling simultaneously infinitesimal and significant, contemplating their place in a story so vast that its beginning lies beyond the reach of human understanding. As you drift toward sleep in your own quiet corner of this magnificent, mysterious universe, remember that you're part of something so profound that even its origins remain gently shrouded in cosmic mystery. Your existence connects you to questions that have puzzled humans since we first looked up at the night sky and wondered about our place in the cosmic order. Your capacity for wonder links you to every generation that has felt awe in the presence of infinity, every mind that has found meaning in mystery, every consciousness that has discovered that the deepest satisfaction comes not from having all the answers, but from remaining forever curious about the questions that matter most. The universe may have had no beginning, or it may have begun in ways we cannot imagine, or it may exist in modes of being that transcend our concepts of beginning and ending altogether. But whatever the ultimate truth about cosmic origins, you are here now, conscious and wondering, connected through the atoms of your body to the first stars, through the structure of your DNA, to the first living cells, through the patterns of your thoughts, to the deepest questions about existence itself. Sweet dreams, fellow wanderer, wherever and whenever you are in the infinite dance of existence. May your sleep be peaceful, your dreams be gentle, and your awakening bring renewed appreciation for the privilege of being a conscious part of this magnificent cosmic mystery we call home.